How many join? 26 has joined. Okay, someone has playing music. Alright. Alright, good afternoon. I would like to start the session today. I hope you can communicate with me in either way by WebEx, YouTube, or on the uh, WhatsApp, or you just turn on your microphone in order to share your points. Something that actually I delayed in giving you the topics for the quiz was that um, I realized that you guys, uh, some of you, when I ask you to fill up the survey form for the videos, uh, you start doing that blindly without even noticing what is in the video. That's why I have changed the course. You will watch the video, and later I will show you the uh, what's that, the QR code that you can scan in order to give your feedback. And in the feedback form, I need you to write down a paragraph about the video, what you have learned about that video. So this paragraph I will give you around 3 minutes to complete. So you can use either a computer. It's better that if you have a computer, you use a computer or your mobile phone. I know you are fast in order to put in the information inside. All right. If I may, I can start the video. Is there anyone has objection about this or no? All right. Uh, I will play the video, and if you don't hear the sound for the video, please let me know.
Hello, Dr. Reza.
Hello? All right.
Hello, Dr. Reza. I'm Adrian Lim, and I'm going to present about my topic, which is electrochemical machining, ECM.
No objection, but will take longer time. Uh, I understand it will take longer time, and we have no options because this is a part of learning. We want you to learn these processes and technologies. If you don't pay attention, how we can verify that you are having the right track in order to learn? So please be patient with me, and then to be in the right track, we will continue this session until 12:20 because we have delay in students joining the class, so it's an issue. All right. Uh, Let me know if you can hear your friend Adrian.
Hello, Dr. Reza. I'm Adrian Lim, and I'm going to present about my topic, which is electrochemical machining, ECM.
Did you able to hear him or no?
No, no, cannot hear anything.
Cannot hear anything.
So, what is ECM? Electrochemical machining is a machining process that
How about now?
removes metal by an electrochemical process. It is also the opposite process of electroplating or galvanic coating. It is an interesting yet effective technique to remove unwanted materials from a workpiece through a very large current.
Yeah, now it's okay.
So it's okay, right? All right. I will start the video.
Hello, Dr. Reza. I'm Adrian Lim, and I'm going to present about my topic, which is electrochemical machining, ECM. So, what is ECM? Electrochemical machining is a machining process that removes metal by an electrochemical process. It is also the opposite process of electroplating or galvanic coating. It is an interesting yet effective technique to remove unwanted materials from a workpiece through a very large current. And the image on the right is how a ECM system set up. For the principles of electrochemical machining, ECM actually works on the basic principle of Faraday's law of electrolysis. So we have cathode, anode, and electrolyte. The cutting tools work as cathode and the workpiece acts as anode. And ECM involves a very large current passing through the electrode and the workpiece through an electrolytic solution. For the working process of electrochemical machining, so first we turn on the electrolyte flow, so there is electrolyte flowing through the system, and the workpiece is assembled in the fixture as shown, and tool is brought close to the workpiece. The tool and workpiece must be submerged into the electrolyte. After that, the current supply is turned on, so there are current flowing through the system, through the workpieces and the tool. This is when the removal of material starts. So the tool feed system advances the tool towards the workpiece and always keep a required gap in between them. The material from the workpiece.
Is it only Amina cannot hear, or everyone else also cannot hear?
I'm listening through YouTube because through Webex I can't hear anything, but the sound is there on YouTube.
Uh, can hear from YouTube or no? But Webex cannot, right? Okay. If possible, please continue on the YouTube.
Come out as positive ions and combine with the ions present in the electrolyte and precipitates as sludge. So since the dissociation of material workpiece take place at atomic level, it gives a very good surface finish. And finally, the sludge from the tank is taken out and separated from the electrolyte. Electrochemical machining actually has many advantages and benefits for our modern use, but the most important process capabilities of ECM is that there are no direct contact between surface and cutting tool. This leads to less heat are produced because there are no residual stress as there are no friction involved, and ECM can manufacture products with good mirror surface finishes. It also has high material removal rate (MRR), and electrochemical machining is also able to cut small and hard metals and able to manufacture complex products such as complex concave and curved workpieces. For the applications of electrochemical machining, it is a process mostly widely used to produce workpieces with complicated shapes, such as turbine blades, jet engine parts, and nozzles. It can also be used as a deburring process to produce smooth and bright surface. Shape tube electrolytic machining, stand for short, is also a variation of ECM that is used to drill small yet deep holes in hard material. It is also used as a numerically controlled machines as it has high production rate and high flexibility. The image on the right shows the typical parts that are produced using ECM. The other application of ECM is also in biomedical engineering. So titanium is broadly used at many fields such as dental, medical, and even biomedical engineering. Using ECM, titanium oxide layer is generated on the machine surface as it facilitates the chemical resistance and corrosion of the titanium implant. ECM is used to utilize the development of cross-flow electrolyte supply system in electrochemical machining. For example, knee plants and knee replacement, which is shown on the right. So the other variation of electrochemical machining is pulse electrochemical machining, which is PCM. So PCM is combined using pulse current into the traditional ECM machining, and it also uses a very high current. And the pulse electrode feed rate in this PCM is suitable for high precision machining. So usually PECM is used for very high precision machining, and the current is housed dead center at the bottom surface, so it can reach much smaller and deeper gaps. Um, the image on the right is the scheme of precise EPCM with applications of pressure chamber, and electrode tool oscillations. So next, electrochemical grinding is also a variation of electrochemical machining. Electrochemical grinding is a combination process of grinding process and electrochemical process. It is also called electrolytic grinding and anodic machining. Um, so in this process, the workpiece will act as the anode and the grinding wheel will act as the cathode. The grinding wheel are usually made of metal plates that consist abrasive particles with strong mechanical properties. So for this process, the electrolytic fluid is pumped through the electrolyte flow to the gap between the grinding wheels and the workpiece. The reaction between the electrolytic fluid and the workpiece will remove most of the metal, while the abrasive particles from the grinding wheels will remove the unwanted pieces from the workpiece. So electrochemical grinding process is widely used for milling, sewing, and grinding. So finally, we have the advantages and disadvantages of electrochemical machining. There are many advantages, and the key advantage of electrochemical machining is that there will be minimal tool wear, less friction as there are no direct contact between the cutting tool and workpiece. Due to this lack of contact, there will be no thermal or heat damage on the workpiece. And the workpiece can also have many varieties and wide mechanical properties such as hardness. For the other key advantage of ECM is that it can also produce a product with smooth surface finish. For the disadvantages, material removal may sometimes be affected by the chemical use that leads to the corrosion of surface of materials. In addition, the materials used for ECM must also be conductive. The workpieces must also have less cavities and less sharp radius. And because electrochemical machining is a very complex process, it requires a skilled person to conduct. That's all. Thank you.
All right. Thank you, Adrian. Okay. 142616. Okay. Please check this QR code. You have 2 minutes to complete. Okay, next we go for the laser beam surface treatment by Ezra. I think the video sound on WebEx is fixed.
Hello
Can you please
everyone.
check? Can you please check if the video on the WebEx is okay or not?
Hello everyone. Greetings to Dr. Reza and my fellow friends. I'm Ezra, and today I'm
Yeah, it is
going to
okay right
present
now.
the assignment one with the topic of laser beam surface treatment. So what is laser beam surface treatment? As you all can see here, the laser beam surface treatment is used to enhance the surface property of a part or a product to achieve the desired result, and it has been developed significantly over the past 20 years. And the medium of this treatment is laser, obviously. But however, there are three types of laser used in this treatment, which is continuous wave carbon dioxide laser, ND-YAG laser, and direct diode laser. So the first one is the carbon dioxide laser. The second one is ND-YAG laser, which is a solid type laser. And ND-YAG stand for neodymium doped yttrium aluminium garnet, as you can see here. And the third type is direct diode laser. So let us now see the working mechanism of laser beam surface treatment. At first, a coherent light beam with high power energy is generated into the system. As it travels to the mirror system, the beam experiences an optical cavity, which makes the photons travel multiple times and causing more and more photons to be generated. After that, the beam travels through the focusing lens to produce the laser with either high or low intensity, because the features of the focusing lens is to modify the intensity of the laser. Let us now look at the general advantages of this treatment. Um, First is it has a high penetration power, and second is that it can improve wear, fatigue, and corrosion resistance. It can also increase hardness and able to treat selective surface. Due to the time constraint, we will just see two types of laser surface treatment. The first is laser transformation hardening. In this laser transformation hardening, the laser beams is used to focus to a localized region for hardening the required portions of a material. And how laser transformation hardening works. At first, the laser beam is heated the top surface of the workpiece to a temperature above the austenitization temperature but below the melting temperature. And due to the rapid heating that results in rapid cooling, there is a phase transformations from austenite to martensite. Here, as you can see, there is a self-quenching and the layer is being hardened into martensite layer. So let us now look at the advantages of this process. The first one is we can selectively heat treat the parts that we want. And the second is there is no external quenching is needed because self-quenching already occur. Third one is there is no post-processing needed because it does not damage the surface. And the fourth is only a minimum amount of heat input energy is required. However, there are some limitations. The first is we are hard to identify the depth of the hardening, and the second one is back tempering. This refers to the uh, hardness of the overlap part to decrease because of the overlap laser track, as you can see in this pictures. And these are the pictures shows in the industry when they are carrying out the laser transformation hardening process. However, there are a few studies that are trying to solve this problem. And the first one is analytical modeling to predict the hardness profile and the hardness depth. As we know that the hardness depth is greatly dependent on the temperature change, hence this modeling allows the researchers to predict the hardness profile and depth without carrying out the actual experiment. and this also helps them to save in terms of time and resources. The second one is laser surface treatment test and analytical thermal model. This is used to solve the problem of back tempering, and the study shows that LSC tests can reproduce the hardness reduction, and this ATM is used to evaluate the thermal cycle undergone by the material during the hardening process. Here are some examples of laser transformation hardening. These three pictures shows different types of parts that are being undergone to the laser transformation hardening. This is bearing, this is piston ring, and this is shaft. Now we are going to look at laser surface pinning. Basically, it is using laser beam to produce a shock wave on a part and induce a compressive residual stress, which really improve the crack and wear resistance. So how it works? At first, an energy pulse is generated and create an impact on the surface of the material coated with protected film and water. When the laser hits the surface, as you can see in this picture, the thin layer of ablative layer is vaporized, and the plasma pressure is then increased when it hits the water surface, and hence a huge shock wave is induced. The shock wave is then cause the plastic deformations in the base material and results in a high compressive residual stress. So we are now looking at the advantages. The first is it can induce a very high compressive residual stress, which is 10 times better than the conventional short turning. And the second one is it is very suitable for hard to reach part and parts with complex geometry. And the last one is it is cost effective and provides longer tool service life. And there is a limitation, which is we are in difficulties in developing a favorable residual stress in thin structures because the depth of the laser pinning treatment is about 1 mm. And there is a current study to resolve the limitations, which is the researchers is using the 3D nonlinear finite element modeling methods to predict and investigate the effects of the residual stress induced by the laser pinning. And this helps the researchers to have a better understanding of the effects of processing technique on resulting residual stress field. And this image shows the 3D nonlinear finite element modeling method of a camshaft. Here are some examples which is used in turbine in aerospace applications, ceramic components, and camshaft. And in conclusion, laser beam surface treatment is getting popular in the industry because it offers a wide range of applications and it has better results compared to other conventional surface treatment. And we can see that there's new researchers keep improving this treatment and solving the current limitations. So I think that laser surface treatments will be greatly used in almost every industry in the near future. So that's all my presentations. I hope this can help you to know more about laser beam surface treatment. Thank you.
All right. Okay, please scan the barcode, the QR code. Okay, have you scanned the Ezra's barcode? Is it finished? I can start the next video or no? Okay, we start the next video from family.
Advanced Manufacturing Technology EPP212. My name is Pailin Sakina binti Masri. My metric number is 142088. This video will present to you about my topic, which is laser welding. What is laser welding? Laser welding is a process used to join together metal or thermoplastics using a laser beam to form a weld. Being such a concentrated heat source, in thin materials, laser welding can be carried out at a high welding speed of meters per minute, and in thicker materials, it can produce narrow, deep welds between square edge parts. Now is the laser welding process based on a schematic diagram. Based on the schematic diagram, the laser beam is focused on the surface of the workpiece to be welded. Next, the laser beam is engaged at the workpiece material, where some of the beams are reflected and the other beams interact with material, which in turn leads to the conversion of light energy into thermal energy. The heat energy melts the surface of the material, and the heat is further transferred through conduction to the bulk of material. In laser welding, laser vaporization is not desired, and this has to be prevented through proper control of the operating energy density that kept the working temperature below the vaporization temperature of the materials being welded. Gas lasers, solid-state lasers, and fiber lasers are the three most common lasers used in laser welding machines. Advantages of a laser welding. Laser welding can work with high alloy metals without difficulty. It can be used in open air. It can be transmitted over a long distance with a minimal loss of power. It has a narrow heat affected zone, low total thermal input, flux is similar metals, no filler metals necessary, no secondary information necessary, extremely accurate. It also can produce deep and narrow welds, has a low distortion in welds, high quality welds, and can weld small and thin components and no contact with material. Disadvantages and limitations of laser welding. For disadvantages, rapid cooling rate in laser welding may cause cracking in some metals. High capital cost for equipment. Optical surface of the laser is easily damaged when working with high refractive material and at high laser power. It also has a high maintenance cost. For limitations, the joint must accurately position. The maximum weld penetration is limited for 19 to 21 mm. Energy conversion efficiency is very low, which is less than 10%. For the selective laser melted technique, the current equipment can produce the limited size of the part. The residual stress associated with the selective laser melted process can lead to component and thread distortion. Next is examples of part manufactured in a laser welding. In Figure 1.1, it shows a laser welded part in electronic application. In Figure 1.2, it is a laser welded part in medical application. In Figure 1.3, it shows a laser welded part in consumer goods. Figure 1.4 is a laser welded solenoid, and Figure 1.5 is the laser welding of a gear component. Applications of laser welding. For electronic application, laser welding has been used because it has a precisely weld line, no particle generation during welding, reduction of assembly time, and improvement of the long-term stability of the joint area. Figure 1.1 gives examples of applications such as switch, housings, ink cartridge, and micro-channel device. In medical application, it is used because it has a faster and a cleaner process, precise welding of a microfluidic channels with a minimal heat affected zone, no particle generation during welding, no contamination, high hygiene standard, reduction of assembly time, and using a single joint technology for different materials. Figure 1.2 gives examples of applications such as medical device housing, tube connectors, and microchannel device. For consumer goods, no drying time is needed as required for adhesive, aesthetical design of welding joint, improvement of visual design, flexibility of a component joining, watertight welded seam, choice of coloration, no additional processing step, and economical benefits. Figure 1.3 gives examples of application as furniture, cleaning robot, watch, and toys. Laser welding also found its application in the aerospace and shipbuilding industries, for welding car bodies, and for welding ship structures. And lastly is the current trend of laser welding. Laser welding technology is expected to register a moderate growth during the forecast period 2019 until 2024. Currently, laser welding is used in numerous different fields ranging from highly precise micro-welding of medical devices to small-scale manual welding in the medical and jewelry industries, from manufacture and repair of dies and tools to fully automated laser welding in the automotive and heavy manufacturing sectors. Improved productivity and reduction of cycle time play an increasing role in current industrial manufacturing, especially within the automotive industry, where the total length of a laser welded seam can add up to more than 50 meters per car. It is important to minimize processing time by means of a high loading speed. A current study from a car at L crack sensitivity of weld can be controlled by making alterations in the process parameters, but this does not apply for dissimilar materials well. So, in conclusion, laser welding shows great potential in the welding of structural steel in general. Its attractive properties include high loading speed, low distortion, and easy automation, give it a bright future in industrial technology. Although it has an expensive initial investment due to its high quality and accuracy, this technology is still being used until now. Here are some references for this video. So that's all for me. Thank you.
Thank you, Pasadena. Okay, the barcode for the presentation. Please scan it. And the right QR code is for the attendance. If you can hear me, please do the attendance. Also do the survey form. We want to start the next video. Uh, are you finished with the attendance? Okay, 28 of you present today.
The topic I'm going
Okay, let's watch the next presentation.
to talk about is laser drilling. Laser drilling is a process of creating holes by using focused laser energy on a material. Drilling with lasers is widely used due to its high levels of precision, productivity, and flexibility. The entire laser drilling process is achieved without any direct contact with the material surface. Mechanism. There are 4 techniques of laser drilling, and each of the techniques are named according to their distinguishable mechanism. So the 4 techniques are shown as in this picture. Okay, the first one is single pulse drilling. A single pulse laser with pulse duration of a few microseconds drill through the workpiece, resulting in blind and true holes. Second, percussion drilling. A consecutive number of pulses to a single point on the workpiece. The third one is trepanning drilling. It works by removing material from the workpiece in a small spot, resulting in an initial hole. Then, it moves in a circle shape and continue removing material until it results in a cylindrical hole. And the last one is helical drilling. Helical drilling is like trepan drilling in a way that it moves in an orbit, a circle, but holes produced by helical drilling is much more accurate because it does not cut the hole in a single round trip like trepan drilling, but removes material on the workpiece layer by layer, gradually. Next, advantages of laser drilling. First, does not require contact with workpiece. Second, almost free from reaction force and does not require clamping of the workpiece. And then it is capable of removing material in a very small amount. Next, very flexible due to not having fixed shape solid cutting tool. And next, very little distortion in machining due to small heat affected zone. And then good surface finish and capable of machining very hard or very brittle material. Next, disadvantages. The holes produced by laser drilling will usually have tapers, particularly in holes that have a large aspect depth width. Molten metal may deposit around the hole. The parameters must be controlled very properly because even the slightest error in setting the parameters, the result will be undesirable. And lastly, cost. Laser drilling requires a considerable amount of investment, and also it uses high power consumption of electricity. How to resolve the limitations? Tapers in the holes produced by laser drilling are caused by non-uniform melt erosion and laser power reduction as it propagates through the hole. Tapers can be removed either by tilting the workpiece or offsetting the laser beam. Thermal and mechanical deformation occur in the workpiece is caused by extended pulse duration. Micro cracks and recast layers can be reduced by adjusting the pulse duration and pulse energy of the laser. Examples of the parts produced by laser drillings are print heads, filters, cooling holes, injector nozzles, aerospace components, medical device components, and electronic components. In conclusion, laser hole drilling outperforms wire EDM, mechanical machining, electroforming, and other processes because the process is non-contact and flexible. Laser drilling allows holes to be drilled in the hardest of materials from aerospace alloys, diamonds, and even coated materials. The hole created with laser drilling is exceptionally precise. The programmable nature of lasers allows very high-speed drilling applications where thousands of holes are required in short cycle times. Therefore, I think laser drilling is a great choice for current and future use in industries. That's all. Thank you.
Alright. Thank you, Lukman. I think I have not created for Lokman the Okay, please scan the barcode. Sorry for the hiccup. Okay, the next video we're gonna review is again on laser. Okay, once finish the survey, I need to start the next video. Please let me know. We have received only 19 responses.
So here we go. First of all, what is laser engraving? Laser engraving is a part of laser manufacturing technology, commonly used to cause permanent deformation to the workpiece in order to produce markings. Laser technology has been developed as early as the 1960s and has since been widely used in a variety of materials. So, what are the difference between what are the difference between normal light bulb and laser light? The difference is laser light emit coherent, monochromatic, and almost parallel light. The versatility of laser engraving has resulted it to be a popular choice among manufacturers. Laser engraving uses focused monochrome light in order to deform the workpiece. Compared to laser cutting, laser engraving only deforms the surface of the workpiece to form letters, numbers, and even graphics. The working principle of laser engraving is similar to any other laser cutting machines. It utilizes spontaneous and stimulated photon emission. So next, we move on to the advantages of laser engraving. I would like to share three advantages of laser engraving. Number one is it can be used on a variety of materials. Number two, it is cost effective. And last but not least, it has low tool wear rate. So the first one, it can be used on a variety of materials. Laser engraving is considered a flexible manufacturing process because it can be used on metals, on polymers, ceramics, glass, you name it. Laser engraving is able to work on those surfaces. So, by being a flexible manufacturing process, it is preferred to be used by lots of manufacturers because it is cost saving and space saving as well. Just imagine in a factory they produce a lot of things and each thing has to have their own machine. So those machine would consume lots of space on the production floor. So by having a laser engraving machine, it can engrave lots of materials in one machine. So it really saves the space of the manufacturing plant floor. And also by being space saving, it is also cost saving because the manufacturers don't need to buy lots of machines in order to process or engrave lots of different materials. The next advantage is laser engraving is cost effective. Yes, it may be a little bit high on the initial, but the process of laser engraving itself, it doesn't consume tools, it doesn't consume lots of electricity, it doesn't consume lots of time. So there are other factors that laser engrave can save. Compared to traditional engraving, laser engraving does not need to have tool change, and the tool does not deteriorate over time, or it does not become blunt over time. So those are the factors that contributes to the cost effectiveness of laser engraving. Next, laser engraving is a highly customizable process. Laser engraving is controlled through computer, and it can be programmed to engrave lots of characters, a lots of image, and a lots of graphics. So it is highly customizable. I mean, the manufacturer can engrave almost everything. Laser engraving, just like any other manufacturing process, is not without its disadvantages. So the first disadvantage of laser engraving is high setup cost. So laser engraving, as the technology is really costly, the machines are also on the expensive side of the price. So manufacturers must decide whether to invest or not in laser engraving machine, because buying a laser engraving machine involves a huge amount of capital, and maybe some of the manufacturers could not afford it just yet. The next disadvantage of laser engraving is it is only limited to 2D planes, which is usually on the XY plane. So laser engraving is not able to engrave, or in a simpler word, draw in a 3D surface. So laser engraving, although it is a good choice, it is limited to 2D engraving only. Up until now, there are no laser engraving machines that is able to do a 3D engraving in terms of the XYZ plane. Lastly, as laser engraving uses laser light, which is highly reflective, it may be a problem to engrave a highly reflective surface such as glass and polished metals. So, in order to combat this problem, manufacturers have to think of a way to handle their manufacturing process in order to have the workpiece to be less shiny, or not shiny at all during the laser engraving process. So it is quite a challenge for manufacturers in order to tweak their process flow of their workpiece. The future of laser engraving seems very promising. Laser engraving has been steadily gaining its popularity among manufacturers, and therefore the demand for laser engraving machines has proportionally increased. In order to cater a wider range of audience, and in order to gain popularity among users, laser engraving machine manufacturers have to work hard in order to meet the demand for the machine. Although primarily used by the industries, there are also demand for personal use laser engraving machines, and the size that is currently being produced for the personal use is almost similar to a 3D printer. So the size is quite small and is more mobile, and surely appeals to personal users that wants to have the laser engraving technology at the comfort of their office. Next, newer machines also come equipped with air assistance technology in which air systems work in such a way that air is constantly blown into the working surface, specifically at the exact burning point, in order to greatly reduce, if not eliminate, flash and defects on the workpiece. So the presence of air assistance in the machining process will also result in a deeper and much cleaner engraving, thus increasing the product quality of the engraving.
All right. Thank you, Lokman. So let's pull up his presentation. All right. I need to announce also that we will continue the presentations next session also. But you need to get prepared for a quiz. The quiz, next quiz that we have, uh, will be around. I think we can start another day, which is not in our normal class. We have to find the time for the quiz because this presentation is necessary, is a part of assessment. Uh, it consists of 20% of your assessment. So we have to complete all this presentation. Otherwise, it would be impossible for me to pass you with the assessment of the video presentation. I need your patience and also cooperation in order to follow the content and also give the feedback which is necessary for us in order to see that you are doing the learning and it is part of the learning outcome. We will cover a few topics. I will put in the WhatsApp group for the quiz. You will have 7 questions at least. And what I want to say that most likely your question will be different from your friends. It's an open book. It's easy. Please be yourself. You don't need to uh, ask from others because they will be busy with their own uh, quizzes. Please complete the form entry, the QR code I share, and then we can conclude the session today. And only 32 of you have signed the attendance, as far as I see. And I'm just wondering, a class which is 37 is receiving feedback for more. Okay, you can open your microphone if you want to give any feedback or you want to ask questions. Any feedback from the floor? May I know how many of you are following from YouTube and how many of you are following from WebEx? If this is working or not. Alright, if you finish with the QR code and the survey, you may leave the room. Thank you very much. We will see you again on the Thursday. Okay, you're welcome.